Right, welcome back. Still on tree diagrams. Right, that example, as I say, generally try to do 3 or more problems. Practice do them over and over and you will get pattern doing. There's a pattern to solving all of them. Identify it, learn it, get used to it. Right, tree diagrams. There are 20 boys and 15 girls in a class. Teacher chooses individual learners at random to deliver a speech. So we have boys and girls delivering a speech. So, number 1, calculate the probability that first learner chosen is a boy. So you can see I have 20 boys. If I count the sample space, 20 plus 15 gives me 35 learners, right? So probability that first learner has chosen a boy should be 20 out of 35, right? So probability, boy chosen first, 20 out of 35, which gives me 4 over 7, or if you want to in decimal form, 0.57. So there are 20 over 35 and the simplified answer, right? Either you write 4 over 7 or 0.57. Right, 4.2.2, draw a tree diagram to represent the situation if the teacher chooses 3 learners, one after the other. So now she chooses 3, she can choose boy, 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 or boy, girl, boy, or she can choose girl, 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 or girl, boy, girl, etc. Right? Indicate in your diagram all the possible outcomes, right? So first the teacher chooses boy, then girl. After choosing a boy, she can choose a boy or a girl. After choosing boy or a girl, there she can again choose boy or girl. Or yeah, after choosing a girl, she can choose boy or girl, right? We come here after choosing a girl, she can choose a boy or she can choose a girl. Chooses a boy for third selection, she can choose a boy or a girl, and here after choosing a girl she can choose a boy or a girl. Probability for boys, if I had to put it on here, should be 20 out of 35, and for girls should be 15 out of 35. Excuse the beautiful handwriting I'm trying, no? Right, so after choosing a boy again, we're dealing with in the form of independent events or not independent, dependent, so I might have to complete. So she chose one of the 20 boys. How many boys are left for second selection? 19 boys, no? Right, and we've already chosen one boy, so that leaves 34 behind. Right, after choosing a boy, if she chooses a boy again, there are 18 boys left to select and only 33 learners left. Right, if she chooses a boy, 20 out of 35. Yeah, after choosing a boy to choose a girl, remember we still have all 15 girls available, but now we've already chosen a boy, so there's only 34 learners left, so that gives me 15 out of 34 for that branch. Right, and then after choosing a girl, if she chooses a boy again, remember we chose one boy there already, right? So I'm left with 19 out of 35 boys. No, not 35, 33, my apologies. Right, and if she chooses a girl, there we've chosen one girl, we left with 14 out of 33 girls. Yeah, oh, by the way, she chose boy, boy. If she chooses a girl, she's left with 15 out of 33. No? The same thing applies here at the bottom. Alright, but I hope you follow, you see the process, right? So if I go through the process again, I've chosen one girl. If I choose a boy, remember I haven't chosen a boy yet, so I'm still left with 20 boys, but I'm one learner less, so that is 34. Yeah, if I choose a girl, I already chose one girl, so there should be 14 girls left, and I've chosen one girl, so the total becomes 34. Yeah, for these two should become 33, so after choosing a boy there, I choose another boy, I have 19 out of 33. No? If I choose a girl here, already chosen one girl. So if I chose one girl of the 15, I'm left with 14 out of 33. So hope you follow, hope you understand. We're still together, right? So we look at the next question. Calculate the probability that a boy, then a girl, and then another boy chosen in that order. So we want BGP. There I chose a boy, girl, boy. Alright? curl, 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 boy, boy, curl, boy, curl. So the only one we have is PGP, where I choose a boy, curl, boy in that order. So all you're going to do is probability of finding that. I'm multiplying my fraction, 3 of them together, right? The outcome, so 20 out of 35 chance for B, 15 out of 35 chance for G, and 19 out of 33 chance for B. So probability that it will be boy, girl, boy, 20 over 35 times 15 over 34 times 19 over 33 gives me 190 over 1309 or 0,15. Right, 1 mark probabilities without replacement and another mark for the answer. Right, next question. My apologies. Calculate the probability that all 3 learners chosen are girls. So now we want P, G, G, G. Ne? So we go look here. Boy, 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 P, P, G, P, G, P, 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 G, 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 P, P, G, P, G, and then G, G, P, and G, G, G. We take the girls. First probability, I can choose a girl is 15 over 35. Then 14 over 35, and I assume here you can see 1 less curl, 13 over 1 less the bottom, 33. So probability it will be GGG would be 15 over 35 times 14 over 34 times 13 over 3, which gives me 13 over 17 equals 0,07. Alright. And last question here, calculate the probability that at least one of the learners chosen is a boy. Right, so if one of the learners has to be a boy, then basically I already know how many girls I have, or if I select girls only, so I can work with that example. So what I'm basically implying, instead of going to choose at least one boy, you see they have a boy, they have boys, 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 they have boys. So to multiply all that outcomes or possibilities is going to be a long process, right? So the only one that doesn't have boys is G, G, G. Right, so I'm going to use complementary events and say 1 minus the probability of getting a girl. Whatever's left behind should be the probability for that on the top. So probability at least one boy would equal 1 minus probability 3 girls chosen. Right, so there from the top you see 3 girls chosen, 0,07. So 1 minus 0,07 then equals 0,93. Hope you follow, hope you understand. Enjoy, all the best. Bye.